Hi folks, this morning I'm looking at my Keurig K40 model unit. We recently began having difficulty with this unit, just couldn't get the water out of the unit. Maybe a little bit of, before we get started, a little bit of useless information here. Keurig, I understand, means excellence in Dutch. Sometimes I think this is excellent, sometimes I don't. But apparently this concept of the single cup coffee maker started in the early 90s by a couple of college students, John Sliven and Peter Dragoon. And in 1993 they approached Green Mountain Coffee of Vermont. And that company saw a practicality in their idea and decided to invest in it. But the relationship between the two concept fellows and Green Mountain was not apparently a very happy one. And by 2006, the concept of the Keurig belonged to Green Mountain with the original concept people no longer involved. They began making these machines for the office first in 1998, and then the home models began to come out in 2004. Now, what I'm repeating here is what I've read on the internet. It may or may not be true, but anyway, that's what I saw. The K40 model was introduced in 2013, and to the best of my recollection, this machine was purchased in about 2016, give or take a bit. Now, before you just tear into this unit, unlike what I did, it's probably a good idea to check a few things. Perhaps one of the first things to check is take a look at your external water tank here. And if you look inside this tank, there is an outlet valve that I'm pointing at with the end of this screwdriver. And there is a screened opening to that valve that can become clogged if you should get some dirt or material in this tank. It doesn't happen too often, but it doesn't hurt to check. And if you have water in the tank, the easiest way perhaps is just to push this while you're standing over the end of the sink. Just very gently push on this. This opens the valve, and see if you get a good stream of water. If that's okay, then move on to the next step, which is to make sure that the openings, the discharge openings, are open. If we remove this K-cup holder here, if you look down in the holder, you will see there is a small, where my finger is at, there is a sharp button which pushes a hole in the bottom of the K-cup for drainage. Now obviously that needle device is subject to being clogged by the grounds located in the K-cup. So one thing to check, I think your manual will show you doing this in the opposite direction, but I really prefer just to take a paper clip and gently shove down the inside of this, if I can do this. And gently work this paper clip back and forth just to make sure that that needle piercing device is clear of grounds. Another place to check is the piercing needle that pierces the top of the Keurig cup, the K cup. And if we turn this unit over, I'll set it here on my knee, hopefully you'll be able to see it. The needle is located right here, and it also has a slot on one side. And hopefully you can see my hand. Don't get rough with it. There are some hoses up above. You don't want to get rough and push the paper clip through the hoses. But again, just to make sure that that nozzle is open. Occasionally that can become clogged and prevent water flow from the unit. Now, if both of those checks are okay, then perhaps the next, or at least in my experience, the next thing I did was to take 2 screws out, and I've already done this in preliminary. Let me get a flashlight here. Maybe the camera, you can see the hole where the screws have been taken out. But I took a screw out here and a screw out here, and that allows you to remove the top covering on this unit. I'll set this back up on the table here. Just gently push back a bit on it. There's a couple of latches in the back, then lift up, and this whole top assembly comes off. Now, you'll see me from time to time putting screws in this cup over here and setting the cup by the piece I took off. Again, this is not a procedure that I followed very religiously in the first time I took this apart, but they do have different diameter screws at various places, and it'll save you from spending a lot of time trying to figure out which screws go into which device when you get ready to reassemble it. Now, as you look here, and I'll again put this in my lap and kind of tilt it over so that hopefully the camera can see, you have the boiler for this unit, and in my particular model, the top of the boiler is a clear plastic material, and you see the 3 tubes hooking into it, and this again is the discharge line from the boiler. It goes through, this is a check valve, and into this needle that we previously cleaned. The next step I would recommend doing is if you take this screw out and this screw out, it allows this bottom portion to swing forward, and it makes it easier to disconnect this tubing from the discharge nozzle assembly. Now, once you've done that, was able to move my lips over the end of it and drew like as though I was pulling through a straw. Now, before you do this, make absolutely sure that this is set long enough that this boiler is cold, because the last thing you want is to have a 180 or 190 degree mixture of vinegar or whatever you have in this boiler. You have a pretty good chance you're going to get a mouthful of whatever's in that, and you certainly don't want it at a high temperature to burn you, so be sure that boiler is cooled off. And the idea when I drew on this was to see if I could get flow through this check valve. As I recall, I had a little bit of difficulty, so I went ahead and cut this tie here, pulled the end off, and then hooked my tube on here and again used my mouth just to blow through it, and the check valve did pop open. So I thought, well, that's not the problem. I'm not sure that I analyzed that correctly at the time, but I proceeded on with trying to work on this machine. So I wanted to take the shell off of it so I could see. I would kind of convinced myself that perhaps a pump or a valve or something had failed internally, because my wife had been trying to clean this unit or descale it, as it's called. And basically a descaling process is, in our household, is that you fill this container with vinegar, and without having a K-cup in it, you run the machine. It pulls the vinegar into the boiler, then it flows out. You do this a couple of 3 times perhaps, well, following the manual, allowing it to set a bit of time in between. And the idea is the calcium products that have come out of the water, hopefully you'll get them dissolved and get the thing back working. Well, the first couple of cycles worked fine when my wife tried to descale it, but I believe it was about the 3rd scale, she got maybe a tablespoon of liquid out of it, and it just quit. Couldn't get any more out of it. So, you know, I'd kind of convinced myself that some component had failed internally. That turned out not to be quite accurate, but I jumped to that conclusion. So I thought, well, I'll just take this all apart so I can see what's on inside. And after I'd had a little bit of difficulty with it, I did go on the internet seeing if other people had taken this apart, and they talked about how hard it was to take apart. And then I began to realize they were absolutely right. Okay, to start the disassembly, we might talk about how this basically is put together. Basically, we have a bottom plate with screws that hold the guts of the unit from the bottom, and then there are 3 plastic tabs around the perimeter here on the top that hold the top to this central shell. So we'll start the disassembly process by flipping it over on its side here, and I will point right here, just as a point of interest. You see a little hole right here. This is, before we started shooting, there was a pop rivet through here, and the ground wires for the unit go to this plate. When I was into this the first time, off camera, why I had just cut the wires in there. You'll see that the wires had been cut and just soldered back together, but you'll need to take this off, and what I plan to do is just put a machine screw back through here when I get ready to ground it again. But anyway, we'll take these bottom off. There are 5 screws involved. And I believe I'll get a cup. Let's see, there were 5 screws. I'm short 1 screw. Well, right here it is. And I think I'll put these in this cup. And then we'll just nudge this metal plate out of the way. Well, that was neat. But here are the ground wires, and you can see that where I drilled out the pop rivet from that hole. But anyway, that'll go back to this spot right here. I'll just set this back out of the way, out of view here. Now the next step is to take the bottom foot off. Here you see the water pump, and if you believe that your water pump is defective, you may have a chance of getting this out. There are a couple of screws back behind here that hold this pump in place, but you may find it even getting the water pump out of the way without taking this out of the shell may be difficult. This is the water intake to the pump from the tank. We'll take this loose. And I'll just leave it attached to the pump. And then there are, and I don't remember exactly how many, we'll just have to do a count here. There's a screw here that holds the shell to the base plate. There's another screw here that I don't think you'll be able to see on camera, right here, that I'm about to take loose. And I'm just thinking there's 3 or 4 screws here, but we'll do a more accurate count here, hopefully in a minute. There's one up here. And I almost believe that's it. Let's see. Yes, that's it. And we'll just pull the power cord out of its strain relief device here. So now the whole center portion of the Keurig unit is loose from the shell, and when we take this apart, we'll slide upward and out. I'll go ahead and put these screws in a separate cup here, things that came off of the bottom. And just as kind of a marker here, there is a transformer right here. I believe it's 14.5 volt output from 120 volts input. You see here are the terminals to the boiler. I believe the boiler is powered at 120 volts, and I believe the water pump is powered off of this transformer off of a DC, probably 12 to maybe 15 volts coming off that power transformer. This is the discharge of the pump coming up. It goes through a check valve here, which you'll see again, and up to the top and into the boiler when it's pumping water. All right, now comes the fun part. There's the shell, of course, stops here, and then we have a top cap here. And the next step is to remove a couple of screws, right? You won't have any trouble seeing them, but well, I say that, I can't seem to get my screwdriver on it here. I'm going to take that hold the back side of this top cap, keep it attached to the central portion of the body of the Keurig unit, and there's another on this side. try to get that out of there. One screw. Second screw. Now you can see the back of this is now loose from the shell. You are not familiar with the Keurig unit, this is actually a vent for air, and also if there is a stoppage inside, sometimes water will flow. When the pump's running, water will flow out of this. That's not a normal situation, but that's a kind of a relief for the pump should there be an issue. Now, the videos I saw said that you could pry this up, as I'm doing, and reach in here and push the clip out of the way, get the top disconnected. I found that I could not get that clip to come loose, even though I could barely see it. And right now it's more visible than in the original when I was trying to get this apart. So this is when I was about ready to get my hammer out. By the way, I think I'll put these screws in a separate cup so I don't drop those on the floor. Because these clips are terrible. Whoever thought this up should have, well, let's just say, shouldn't be allowed. And there is another clip all the way on the back side, back here, and the directions, I was told that you could reach through the top with a screwdriver and push that clip loose. I could never see that clip on that side. So when things really went bad, after fighting this for a while, I don't know whether we can get this around and get light conditions where you could see and hear or not. Okay, now you're looking in at the top, and I took my soldering gun, my Weller soldering gun, and put a flat tip in it. And I went first across here and then down a little bit and cut this out. Obviously this, I did not want to melt this white tubing that you see here. And once I was able to locate where this was at, I went ahead and used my soldering iron again to cut down the side, just completely opened this up. Yeah, it kind of did a butcher job on it, but I could see the clip then, which I don't believe is visible on camera. And I reached in and tried to push and get this clip to come loose. It still refused. So finally, the clip, top of the clip is about right in here. I just pushed my tubing out of the way with a screwdriver and just cut the clip, arm and everything completely off from the top of the assembly here, and got that particular plastic clip out of the way. Then I moved on around. I could now lift this sort of in a way that you see here. And I took a knife blade and inserted here. And this other clip is just about right here. As I begin to pry up, strangely enough, it did come loose. And Actually, I can see the clip. I don't know whether you can in the camera or not, but my knife, tip of my knife is pointed right on it. And there's another clip just about in line with this push button in the back. And I worked my knife on around, trying to not damage the circuit board. This is the terrible part of this. You're just never quite sure whether this thing is going to survive. Whoa. Whether it's going to survive the rough treatment you give it or not. And lo and behold, when I stuck my knife, and this time I used a screwdriver because I had mutilated these clips to where I can get them apart. Of course, this clip is going back into its little socket there. Now then, I'm going to move this to my lap. Hopefully my camera person here can keep up with this. And pull. And as you see, I'm starting to separate this entire assembly. From the shell. Whoops, hung up here. And that's it. Now you can see one of the remainders of the clip here, and it's actually originally had a little hook on the back side, and that hook went into these, let's see, that particular one went into this bail, went through it, and then hooked on the back side. Well, that's great, except there's no way to get to it to get it disconnected. So again, I took my handy dandy soldering iron and just cut the hook off, because the next time I'm going to be into this thing, I'm just not going to fight those plastic hooks. Seems like it was all kind of an effort to make this thing almost non-repairable. So now we see we have the unit out, and I'll just kind of point out some of the features here. Here you see a translucent top. Now I understand not all of them are translucent, but fortunately mine is. You can see, if you can see my finger there, it's on the top of an electrode. There are 3 electrodes here and going through the top of it, and there are 3 connections going into the unit. The bottom part of the boiler is made of metal. Looks like it's probably stainless. My screwdriver is touching it here. And additional features that we've got that we can see at this point is this that I've got my screwdriver on is an air pump. And this is an electrically operated solenoid valve. And here laying on top of the table is the water inlet with the water pump out of sight back in the bottom. So I believe, now I haven't spent a lot of time studying this, but just my observations, so if I'm in error here, I'm not lying to you, it's just ignorance on my part and not enough study. But basically what seems to happen is that when you press a button to select a coffee, a size of cup that you want, you've got, this one has 3 different sizes. Let's say you select the middle size cup. I think that's maybe 8 or 9 ounces or something like that that's supposed to come out of it. This pump down here will come on for a few seconds, and simultaneously when the pump comes on, the solenoid valve opens, And the reason this solenoid valve has to open is that the pump is going to try to pump water into this boiler, which is sealed up. And so air has to be allowed to exit out of the boiler in order for the water to come into it. So air will come down through this tube, through this solenoid valve, back up, kind of out of sight here, and it'll vent through this opening here. So the pump comes on, the water comes up to, I believe it, in this case, it'll come up to the second electrode that's sticking into the solution. I believe that's this one right here, if I haven't got them confused. And then it will stop. And at that point, then the solenoid valve will close, and it's ready to dispatch the water from the boiler into the cup. Now the water, you always have a good supply of water in this cup, in this boiler, and the additional water is, you know, they have to have it up to maybe 180, 190 degrees, so a few more ounces of water does not lower it. It's still probably above a comfortable water drinking temperature. So when this boiler has reached that electrode, the circuit board turns on this air pump, and the air pump pumps through this tube up through this device into the top of the boiler and begins pressurizing the top of the boiler. This pushes on the top of the water, and the discharge line, the connection on the discharge line, the tube actually goes down much near, not all the way to the bottom, but near the bottom. So basically, the top is pressurized, it pushes the water up, it comes up through the discharge line here, through this check valve, down through the needle, and it's dispensed into the cup. Now you see a tube also right here connected to this air line. It goes up to the circuit board located in the top. And near as I can tell, when this cup, when the water is dispensed, the air pressure starts to fall off, because now it's just blowing air through the discharge valve. In fact, you may hear it, the hissing sound that you hear at the end of the dispensing cycle is air continuing through there. There's a little pressure switch on the circuit board, and this tells the unit that it has completed a dispensing cycle, and it stops. And you have your cup of coffee, you pick it up and hopefully drink it, and I'm very happy. So there's a lot of odds and ends of things that can go wrong. There's also another small tube that you may have noticed here, same size as the air tube, and it goes down through here, but it is not connected into the air line. It goes on down, and it is actually connected to the discharge of the pump. And I believe that this is like a pressure relief line in case there is say the solenoid doesn't work or something, and the pump is unable to move water into the boiler. Then it'll come up, water will actually come up through this small tube and be discharged here. So if you see a situation, I mean, a few drops is no big deal, but if you see a situation where this water is running out of this vent hole, normally this is only venting air, then that's a pretty good indication that you've got some kind of a blockage between your pump and the inlet to the boiler. And that discharge from the boiler is coming up here, from the pump is coming up here, and discharges into the boiler right here. Now, one of the things that I did while I was working on this, kind of stumbling around, is I cut the tie right here, disconnected the check valve, or the one-way valve, and I just connected this fuel line, it's a 1/4 inch fuel line, onto the end of this hose. I also took this line here, which is the air relief line, loose at this connection. I pulled this line up above and then inserted this line into a container of vinegar, and then just with my mouth drew on this line and pulled. Basically what happens, this is the air relief line, and I created a low pressure in here and manually pulled vinegar from my jug into this boiler. What caused me to do this, when I looked down into the boiler, I could see a good deal of white material all around the base of it, which is of course probably the calcium compounds that had separated out of the water and collected on the heating element. And also even on the discharge line, I could see it almost looked like the discharge line was partially blocked. So as I said, I hooked this line up here, put this into a tank of vinegar, and then sucked on this line just with my lungs, my mouth, and basically filled this boiler up till manually until I could see the vinegar line was right up to nearly to the electrodes up here. And I just let that sit for an hour or so, and then I reversed that process by blowing into this. I pressurized it again just by mouth, and then I took this line and just drained it out into a cup, this vinegar that had been in the boiler. And I was pleased to see that after sitting for an hour or so, the white compound seemed to have pretty much dissolved. I think that really the only problem this particular unit had was that when we began to do the descaling, or my wife began to do the descaling operation, maybe there was a bit more of the solids inside the boiler than usual. Some of those, instead of dissolving, they actually kind of crumbled loose, leaving a combination of a powdery, almost sand-like material in here. And I believe it came up intended to block this check valve. Well, in this measuring cup is some material, that vinegar actually, that was used to descale a vaporizer that we used in the house for humidifiers. Now, in other words, this is a similar process to descaling this boiler, except the heating element's completely exposed. And this material did not come out, I want to emphasize, this material did not come out of this Keurig unit. It came out of a vaporizer unit, but it's a similar issue. If you look into this cup, you can see a good many solids in there that came out as a result of the descaling operation. It could be these solids were also generated inside my Keurig unit, and they may have been instrumental in plugging up my check valve, the check valve that is on top of this unit. So I'm not sure the chemistry involved here. And I don't know, again, we were using vinegar as a descaling material. I don't know whether the Keurig descaling material does not produce this precipitant, but chances are it's a similar process of the mild acid dissolving the calcium product. And somehow there is some solids left over that maybe if there is enough of them, they could go up and clog discharge openings and so forth. So it's another thing to think about if you're in one of these units. Well, in summary, I think you probably have realized that I made this job much harder than it really needed to be. I've taken the unit just sitting in here on the floor. I've got the top cap loose. And again, this is a check valve, and that goes down into the dispenser into the K-cup. And I thought maybe it was worthwhile, just as kind of a follow-up note, to if you think that your issues have to do with solids that have built up in the boiler, this approach might be of some interest to you. So I alluded to this earlier, but I thought I'd show it in a little more detail. And I've cut the band that holds this to the check valve. I'm going to pull this loose right now. And I've also taken, this would be the air release line here, and this line coming up here is the fill line, from the pump down below, water pump down below. So I've already taken these lines loose, and for this demonstration, basically, one of the thing that I had suggested doing was to just hook up a temporary line. This is a 1/4 inch gas line that I had out in my shop. And if you think you've got just blockage issues, just blow through the check valve like so. You can hear it when I blow through it with my mouth. The valve opens up. If I try to draw backwards, the check valve will close and not let flow go backward. But I think in this particular case, my problem was that I had some loose solids floating around in the boiler, solids being calcium compound from our water, and those had come up through the discharge line and actually had blocked this, and I just really didn't realize. And this check could be done without taking the shell off, without tearing the unit completely apart. But of course, at least in this case, I had the pleasure of seeing what's inside this unit, so that was kind of interesting. But what I had suggested doing, this being again the discharge line, it has a dip tube that goes down almost to the bottom of the boiler. This is the water fill line that's still connected, and this is the air line that I have disconnected, and just goes through the top of the boiler and opens up. So one technique that could allow you to do a bit more detailed descaling, particularly if the unit's really acting up and it's clogging this valve, is you could just couple on this 1/4 inch tube with I have a fitting here, 1/4 inch fitting. Just drive this in, and then run this tube into the top of this bottle of vinegar. And then if you connect this tube to the air relief line and you try to draw through it, what'll happen is, or maybe you can hear this, that gurgling sound is actually air that I was drawing through the fill line, the water fill line. So if I just reach down here with a plier and gently pinch off this line, and then I draw on this, I can draw vinegar straight out of the vinegar bottle into the boiler and actually completely fill the boiler full of vinegar. Then I would suggest leaving it for an hour. If you're really having difficulty, just leave it for an hour and a half, and then when you're through, after this delay period, you can take this tube and then just blow through it, and you will pressurize the top of this just like the air pump does, and you'll pressurize this, pushing the vinegar out into a cup, and it gives you a way to do this manually and do a much deeper cleaning of the boiler, particularly if you have waited too long and it just really has a lot of solid compounds in it. Our water here we live in the country, and our water is really pretty hard, so we get a lot of solids if we don't keep this thing treated on a regular basis. But anyway, what I'm trying to say is this could probably have all been done, a couple of minutes to take the top off, 5 minutes to fill the boiler, and then let it dissolve the calcium compounds, then blow the vinegar back out, and I could take a light shine down there. If I could still see calcium deposits in the boiler, I could refill it with vinegar and give it another hour or so. And I'd certainly recommend that from an efficiency standpoint. Recommend that over what I did, because having taken this entire thing apart and finding really there was nothing wrong other than I was not getting flow out of the unit, it will save everybody a whole lot of time to do it that way. Well, I appreciate y'all watching this. I hope it helped you out, and I'll see you next time.